So let's jump into the deep end and make our own BlinkScript kernel. Specifically, let's make a variable defocus BlinkScript kernel, kind of like a Z defocus. We're going to make it a little bit simpler just to get the key concepts out there. But this is a really great first step because making a defocus has so many little bits and pieces that all come together to create a complex output, and is a really great introduction to writing our own first BlinkScript. So the first thing we're going to do is we're going to grab our blank BlinkScript kernel, and as we will remember from the previous video, all this does is it takes our source and outputs it to our destination, like so. So there's no change. Now I've grabbed a checkerboard, but what I'm going to do with this checkerboard is I'm going to add some noise. And the reason I'm going to add some noise, and I'm just going to make it a really fine, crunchy noise, something like, let's see, let's push this a little bit further. Something like this, is so as we are defocusing our image, we actually have something we can see. Because if we didn't have that noise, it would just look overall quite soft. And you know, from this you can probably figure out if your defocus is working. But I like to make sure we've got a really, really crunchy set of information so that we can really see those kernels. Now the next thing we're going to do is within our image, specifically within our image section of our BlinkScript kernel, where we read the image or how we access the pixels, we need to address this in a slightly different way. At the moment, by default, BlinkScript does something called access point. And if you don't include anything, like the way we're writing our image here, has nothing, but we could do the same thing where we write access point. What this does is it goes across your image pixel by pixel, and it says, okay, as I'm processing this pixel, I'm only going to access the source from this pixel. And as you move across pixel by pixel, it does that same thing. Now, there are 4 different ways we can access our image with BlinkScript. The first is access point, which only accesses this one pixel. The next one is access ranged. If I can spell it correctly, it'll change blue. Ranged 1D, and what this does is it will access your image in one dimension, either in X or in Y, depending on how you specify it. You have access 2D, which will access the image using 2D coordinates from your origin pixel in the middle, or you can access random. And if I just do this, it will go blue. And access random allows you to directly access any pixel on the image by giving it the direct coordinates as opposed to the relative coordinates. And for this, we're going to be using access ranged 2D, because when an image defocuses, it goes out from your central pixel, and that's how we want to access our pixels. Now, when we're dealing with access range 2D versus access point, there's a few extra steps that we need to do. And this is specifically, we need to tell our BlinkScript how large of a range to expect. And we need to tell our BlinkScript the relative coordinates of the pixels that we want to work with. So the way we set the range of our ranged 2D is we come down to the init section of our BlinkScript, and this is what will be ran when it initializes. And we need to just make a new line and tab in, and we need to write a little line here that says source.setRange, and you'll see it goes blue, which means it's working. We want to make sure we put a semicolon at the end of our line here, and the reason we want to put that semicolon is because that is how in BlinkScript, which is similar to C++ like languages, how you finish your line. Those of you familiar with Python will know that we could just leave it like this and it would run fine. But when working with BlinkScript, you need to make sure to leave this in. Otherwise, you spend forever trying to figure out why your code doesn't work because you just left out a semicolon. And now when you're doing set range, you need to actually set the values. And the way this works is you specify your negative X, like so. Then you specify your minus Y, and let me just click in here, minus Y. And then you do your X, and then you do your y. And so what this is doing is you're telling BlinkScript, okay, we're going to have values this far in minus x, this far in positive x, this far up, and this far down. But you don't just leave minus x, minus y, etc. in here. We need to actually specify the numbers. And in order to specify those numbers, what we need to do is we need to create a parameter that will control them. We need to create a parameter that is going to control our defocus size. And the way we do that is here in our parameter section here, we're going to write int, which will create an integer variable, and we're going to create the variable called defocus size. We're going to put a semicolon here. And then additionally, what we're going to need to do is we're going to need to now define this parameter that we've just made. And the way we do that is within the define section. And the way we're going to do this definition is we're going to say, okay, define param, which is obviously short for define parameter. Next up, we have to give the name of the variable that we're going to define, which is obviously defocus size. So I'm going to copy and paste this. Next up, I'm going to do a comma, and then I'm going to put some quotes here, and I'm going to say what I want to name this variable. And this is this name is what's going to appear like all other nods on Nuke nodes, like so. And so this we're going to write in a sort of more user-friendly way. So we're going to call this defocus size, and then we're going to put a comma, and then we're just going to define the default value. So for example, on this one, just like the regular defocus node, I'm going to Control-Shift-X to pop this out. The default defocus node, as with most filters in Nuke, you know what? This comes in as a default of 1. So let's define this to have a default of 1. I'm going to put a semicolon at the end here, and now when we recompile this, we are actually still going to have an issue. You can see we've got an undeclared identifier x, and what this means is that where here we've set the range, these x and y's that I was using for demonstration aren't correct. They haven't been defined as anything. So what we're going to do is we're going to copy the name of our defocus size, and we're going to paste that in these boxes here. And what this is doing is this is saying, okay, the range that we need to access our pixels is never going to be greater than the defocus size we're feeding it. Now, when we click recompile again, we're going to see what our next issue is that we need to solve. Now we can see that there is an error on line 32. Now, if we go down to line 32, we can see this is where we are accessing our source image. Now, you might remember, as opposed to using access point, when we're working in access ranged, we need to give the coordinates of the pixel we want to read. So for this, we're going to say 0, 0, which is reading our origin pixel. You can see it looks a little bit like an owl, which is how I like to remember it. Now, when we click recompile, you can see we're feeding through our image nicely here. But now when we go to our kernel parameters tab, you can see we have this defocus size integer knob, and I'm middle click sliding here to change those values. I'm going to set this back to 1. Now, the way reading these coordinates works is quite interesting. It's slightly different to how you might expect. Now, when I see this and I see these coordinates, my mind is immediately sent to the transform node, or maybe the position node, which allows you to translate your image in X and Y, and the transform node obviously has lots more. But if I, for example, put a value of 5 in this box, you can see my entire image is moving 5 pixels to the right. But if I was to put a 5 in my X coordinate here, because this is X and Y, when I click recompile, you can see the opposite is happening. My image is moving 5 pixels to the left. And the reason for that is because what's actually happening is it's pulling the pixel. So if we take this black pixel as our center, we're going 1, 2, 3, 4, 5. You can see we have this nice gray pixel here, and it's pulling that 5 pixels in the opposite direction. So you can see when this is disabled, it's here, and then when it's enabled, it's 5 pixels to the left. And this is a good way to check if our parameter is actually working. What I can do is I can grab this integer here, put this in this box, recompile, and you can see now as I move this slider, our image is moving with it, which is great. That means that so far everything is working as we'd hope. Right, now that we've got the skeleton of our BlinkScript sorted out, let's see about actually getting ready to do our defocus. Now, when I'm working with BlinkScript, what I like to try and do is start from Nuke native nodes. For example, using a transform here to deal with this pixel offsetting, because this is something that Nuke native nodes I think we're more familiar with than necessarily starting our BlinkScripts from scratch. So for a defocus, what we need to do is we need to actually take a look into convolving. So the way we're going to do this is, first things first, we're going to create a radial, and we're going to use this as our filter to convolve the image by in order to create our defocus. And don't worry if this sounds a little bit abstract at the moment, it will all make sense. And then what we're going to do next is we are going to create a reformat node. We're going to set this to box. We're going to force the shape. And for now, we're just going to do 15 by 15. And now when we plug our radial into this, you can see it's much too large for our small little box. And so what I'm going to do is I am going to make some expressions here. And so the first one, I'm just going to do 0, 0. So the bottom left corner of my radial is always in the bottom left corner of my format. And then on this one, I'm going to write width. And on this one, I'm going to write height. And then after that, I've accidentally set a keyframe. What I'm going to do is I'm going to set my softness to 0. And now what this means is, and just for the sake of simplicity, I'm going to control click an expression link this here. It means as I make this bigger and smaller, we're getting a larger and smaller radial. And now what we can actually do is create a convolve node. We're going to use this radial as our filter. We're going to plug this noise node in as our image. And now when we plug this into our convolve, you can see we are defocusing our image. And that's what on the inside, effectively that's what a defocus is. So if we do the same thing, this one, so we're going to set this to 15, and then we're going to set this to have a defocus of 15. What we might need to do here is we might need to double this and set it to 30. And so you can see these two are having very similar, they're not exactly the same, but they are very similar results. And so this is a great way of getting like an estimate of what we are going to be working towards. And so you can kind of see our steps that we're going to be building in our BlinkScript kernel. We're defining the size here, which is what we've done with our defocus size. Now we need to make a radial, and then after that we can focus on convolving. So the theory of how this is kind of going to work when we go to write our pixel and how we actually write the convolution is our BlinkScript is going to internally have a radial like this, a sort of virtual circle that it's going to be considering when it's going in our image. And what it's going to do is it's going to cycle across this virtual circle as we go from the center of our pixel outward like this in our sort of in our convolution. And then what it's going to do is it's going to say, okay, I'm going to walk across every pixel in my image like this. And if I come across a pixel that isn't black, like these pixels here, I'm going to add them all together. And then we're going to keep going along, and it's going to do the same. It's going to say, okay, I'm going to add this pixel. And when I say this pixel, I'm talking about this pixel relative to the central pixel that we are dealing with. So if I merge this over the top of this to make this really obvious, and I'm going to create a black outside node around this, and all this is going to do is it's going to add an extra row of black pixels so we don't get this smearing. So if I were to just transform, and I'm going to transform this by integers, if I was to transform this over, and I'm just going to reduce the transparency a little bit, and to make it really obvious, I'm going to make this just red. And so what it will do, let's tidy this all up a little bit so it's nice and visible. Right, so what this will do is it will start from the central pixel. I'm going to pick a different color so that we don't clash. Brilliant. So it will start from this central pixel, and it will go out by the width and height of our radial, and it will walk across, and it will say, okay, any pixel that is within the radial, I'm going to add together like so, and it will add this pixel, this pixel, this pixel. It will ignore the pixels outside the circle. It will combine all of these together. It will then average them all by dividing by the number of pixels it's counting. And then it will assign that value to the center. So it's basically taking an average of all of these surrounding pixels. So that sounds quite easy to say, or maybe it doesn't, but as we go step by step, it will. But the first thing we need to do is say, how do we actually define a circle using just code? Now, again, before we jump into BlinkScript world, let's see if we can do this with a Nuke native node. And I am going to grab an expression node for this, and we're going to write an expression to define a circle. So let's start by first defining one of our expression variables. We're going to call this one radius, and we're going to use this to drive the, you guessed it, radius of our circle. Now, if we look at our expression node and we just type radius in here, the whole thing is going to have a value of 50 because that is the value of our radius. And I'm just going to plug this into our checkboard. I'm going to delete a lot of the stuff we don't need anymore and just keep everything nice and tidy. Let's square this off to start working over here. Brilliant. So this has a value of 50. Now, what do we need to do next in order to define our circle? Well, a circle, we need to use our X and Y coordinates. And rather conveniently, if I write X and Y in here, we're going to get this very, very bright image. But wow, this is actually very pretty. You can see as we start in the bottom left-hand corner, our green, which is our X, and our blue, which is our Y, are at 0, 0. And when we go all the way to the top right-hand corner, you can see we've got 1919 and 1079. And the reason for that is because we started from 0, and then you count all the way up, and it's 1 less than the format because we started from 0. So next up, what we need to do is we need to look at a power function. Now, the way you do this in an expression node is you can just write pow, which is short for power. And so I'm going to do this in a new section. So if I here write pow and then put my brackets, x, comma 2, that is going to do x squared, which would be the same as writing x to the power of 2 like this. But the reason I'm using this power expression is because this is supported within BlinkScript, whereas this double asterisk is not. Now, what we're going to do is we're going to subtract this from our radius, and I'm just going to 0 these out so it's nice and easy. And you can see here, we've got this fall off in our x coordinate. Now, next thing we need to do is we need to do the same thing with our y coordinate. So to do that, we're going to do pow again, and we're going to square it. And you can see here, we have this very interesting sort of diagonal, almost diagonal line. You can see it ramps up just a little bit here. And now what we need to do is we need to actually put some square brackets, not square brackets. We need to put some brackets around these so that these get added together before the subtraction happens, which means we get this very nice little circle here. And now at the end, I'm going to write I'm going to turn this into an expression. And the way we're going to do that is we're just going to write greater than 0. And what this is going to do is it's going to return 1 when this value is greater than 0, as opposed to a sort of sliding ramp. And if I make this number bigger, you see this becomes quite obvious. I'm just going to say we want 1 or 0. And now we've just turned it into a question. So now that we've done this, something you might notice is that actually we don't have a radius. If I do, and what I'm going to do is I'm going to move this into a different channel so it's more visible. You can see that this radius is only 23 pixels, not 500. And the reason for that is because we need to do an extra step. What we need to do is square root our expression here that we're subtracting from the radius. And the way you do that is you just do power, and then we're going to do this entire thing to the power of 0.5 like this. And now you can see when I move my slider out, this has a width of 500 pixels. Now, you can either leave it like this, or there is an expression that is available within BlinkScript, which we can take advantage of here just to show multiple ways to do the same thing, which is you can actually write squirt, short for square root, here and achieve the same thing. And now we can see if I write 700 in this, we get a 700 radius like so. And this is all pivoting around our 0, 0 origin. So this is actually expanding out into this area here, but we're not writing those pixels because they're outside of our bounding box, those negative pixels. But when we go and move this over to our BlinkScript, those will be useful. So we're going to leave our expression here for a moment, and we're going to move on to the next little bit. Although, because our filter is going to pivot around the 0, we don't need to change this. If you ever do, for other reasons, want to control your radial like this, and I'm going to make this just a little bit smaller so it's easier to deal with, you can do an offset here, and similar to pulling the pixels from other places, it's a negative value. So you could do minus 500 by minus 500, for example, and you can see what this has done is it has offset the center of the pixels to be at, I could get this exact, but it's at minus 500, minus 500. So what I like to do with this sometimes is I will create like a 2D position knob, and I will call this center. And then I like to do minus center.x and minus center.y. And we don't necessarily need that for what we're doing, but this might be useful for some other stuff you're doing, just to kind of explain the concept as just a little freebie bit of extra knowledge. So now that we've made our circle equation, what we need to do next is we need to create some loops inside of our BlinkScript in order to loop across these pixels for our defocus. And the way we're going to do this is we're going to do this within the process section of our script. And we are going to come down and tab in like so. And first things first, we're going to write for, and we're going to put some brackets. And this is how we're going to start our for loop. And what we're going to do is we're going to loop across our X pixels and our Y pixels. But what is a good little trick is if you loop across your Y pixels first, BlinkScript is optimized in such that when you do Y before X, everything runs just a little bit faster. So rather than doing X and Y, here we're going to do Y then X. And the way we do that is within our loop, we're going to create a variable. We're going to create an integer, and I like to just use capital Y for that. And what we need to do is we need to specify, okay, starting from our origin pixel, start from minus Y, and then walk all the way up to the positive defocus value. And the way we do that is we do equals here, and then we do minus, and the value is going to come from defocus size up here to specify the size of our looping. So we're going to do integer Y equals minus defocus size as our starting value. And next up, we're going to define the condition that needs to be met for the loop to continue. And for this, we're going to say Y is less than or equal to, and we need to make sure this is a Y. So Y is less than or equal to our defocus size. And what this means is as we are counting along our Y pixels, it's going to go from the negative all the way up to the positive, and this little equals is going to make sure we include the this top pixel, otherwise it will get missed out. And then we're going to do another semicolon here as well to say that we're done with this section of the for loop, and then we're just going to do Y++. And what that does is it will count up by exactly one integer as we go through the loop. And now here we're going to do a squiggly bracket, and we're going to tab down just a little bit more, put another squiggly bracket, and everything within these two squigglies is going to be looped over. And now what we're going to do is we're going to copy this line, we're going to come down, tab in, and then we are going to make sure to indent, and now we are going to do our X pixels. And then just like before, we need to indent in correctly, like so, and put a squiggly here. Now, those of you familiar with Python will know that indentation is extremely important, and if your indentation isn't correct, your code won't run. In BlinkScript, this is slightly different, where everything is mostly defined by things like our squiggly brackets and our semicolons and things. But just to keep our code human readable, the indentation is still incredibly important. And now what we need to do next is actually specify what pixels we want to operate on within our looping. Because if we just use this for loop and said we're going to convolve based on all of these pixels, you would get a sort of boxy defocus. So we could imagine this where instead of using a radial, we'd be using something like a rectangle. So if I just grab a rectangle and scale up like this, I'm just going to scale it over so it's fully sized. This would be the equivalent of defocusing something like this as opposed to our circle, which maybe you do want that. Things like erode fast, which if you ever wanted to replicate this, this does use a square filter. So, you know, it has its place, but for us, we want to specifically say we want to operate only within the bounds of our circle. And similar to what we've done with this expression, where we have this greater than 0 here, we need to specify an if statement. And the way you format an if statement is a little something like this. So if we just tab in like so, and then indent even further, we put our brackets like this after we've typed if, and then just like with our for loop, we put some squiggly brackets at the end, and we put some squiggly brackets here, and then do some more space for us to work in, and then even more indentation just to work inside of. And now within our if statement, what we're going to do is I'm going to control double click on my expression node here, just so we have our expression here to refer back to. And what we're going to start doing is we're going to retype this expression, but in a more in a way that will work for our BlinkScript. Now the first thing here is we've written radius, and the way we're defining our radius in our BlinkScript is with the defocus size. So I'm going to write defocus size in this box. So now that we've specified that radius, let's go through and sort of rewrite everything we have here in a way that is compatible with our BlinkScript. Now, first thing first, I'm just going to get rid of our radius, not radius, I'm going to get rid of our center pixels here. And so what I am now going to do is I'm going to say defocus size minus, and the square root part we can keep. And then within our square root, and I'm just going to space everything out so it's a bit more easy to read. So we're going to have our square root, and within this, we're going to write our. And now instead of the lowercase x, which is what our expression is using, we're going to use the uppercase x here, the capital X, comma 2. Now there is a quirk in BlinkScript, and if we were using the power function here to the 0.5 like we did before we made it a square root, we need to change something. Because we're writing 2 here, and 2 is an integer, we can just leave it as is. But if we were writing 0.5 here, in order to specify that this is a floating point variable, a sort of decimal number, or if we were doing 2.5, the story would be the same. You need to just put an F at the end to specify that it's floating point. But we don't need to worry about that here. So I'm just going to write power x squared. And now here, I'm going to write, do another space, do a space here. Just keep everything nice and spaced out. We're going to do this to our y as well, like we've done here. Oops, a daisy. And then just within our outermost bracket, now I'm going to start to shrink this down again now that we're not working in that area. What we need to do is we need to say, okay, our defocus size, and this entire expression needs to be greater than 0. And I might be a little bit I might overuse brackets just a little bit too much, but I like to just be absolutely thorough to make sure that I'm not making any mistakes. I'm going to put some brackets in here, and it's also a good way of just visually seeing everything that we're doing. And so now what we've said is, as we loop across these pixels like so, if the pixel that we're looping over is inside our sort of virtual circle, the code in this section is going to be done. So let's jump straight into that part. Now what we need to do is actually define what we're going to be outputting and how we want to manipulate those values. Now, working directly from the source like this for something simple is fine, but when we're working with something a little bit more complex, we need something a little bit more sort of malleable. And what I like to do for that is I like to create a float4 variable called output. Now, a float4 variable specifically means we can assign red, green, and blue and alpha values to that. And the way you would do that is with output.x for red, output.y for green, output.z for blue, and then output.w for your alpha. And then what I'm going to do is, for now, I'm just going to assign this a value of 0 so that it has some data to call from. Because if we just leave this as output like so, and we don't give it a starting value, when we come to call this value in a minute, we're going to run into some issues, because by default it has no value at all. Not a value of 0, no value. And so what we're going to do is, here in the if statement we've just made, we're going to define our output further. We're going to say output equals, and then we're going to say output equals output plus source x comma y. And so what this is going to say is our output value is going to now equal our original output value plus the source pixel at the x and y coordinate as it goes across and loops across all of these pixels in our filter. Now, what does this actually mean? Well, I'm going to delete this and sort of show you a slightly different way of writing it. What you could also do is say output plus equals, and then that same source x, y value. And what this is saying is we're going to take the output value and we're going to add the original output value plus our source. And so what this is effectively doing is, if I did output plus equals 10 and our original output value, for example, had a value of 5, what this would do is it would say, okay, output equals 5 plus 10, which is 15. Then the next time we come back around, it will say, okay, now it equals 25, then 35, and so on and so forth. And so here, I'm going to source x and y. I'm going to copy this, and I'm going to say, okay, our destination now, our pixel we're writing to, now equals that output value. And let's see when we recompile if all of that actually works. Dun, 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 dun. It does indeed. Now, as we scale this up, you can see it very quickly, these values are absolutely ballooning. But if I bring the exposure down, you can see hiding in the background, we actually have some defocusing happening. Now, why is it getting brighter and brighter and brighter? That's because we haven't included the normalization step, the averaging of all of these pixels. All it's doing is getting brighter and brighter. And that is very similar to, if we didn't tick normalize on this, we would end up getting the same result. And so the way we're going to do this is we're going to say, okay, every time we add a pixel to, every time we add a value to our output, we're going to keep track of how many pixel values we've added. And then at the end, we can divide by that normalization. And the way we're going to do that is we're going to say, okay, underneath where we've defined our output here, we're going to define an integer variable called normalizer. And then we are also going to give this a value of 0 because it's going to start with, well, when the script starts, we haven't processed any pixels, which means we're going to start this counting from 0. And now underneath our output, when we meet the requirements of this if statement, what we're going to do is we're going to write normalizer plus equals 1. And this means it's going to count up as it goes. And now what we're going to do is after all of our loops have finished, so after this squiggly bracket here, we're going to say, we're going to take our output, we're going to say it equals our output. Let me move my mouse so that that is visible. There we go. Our output divided by our normalizer. I'm going to put some a semicolon here, or we can just write divide equals like so. So now when we recompile, you can see we've got a nice silky defocus that has been normalized, which means as we change our values, it's going to behave. Now, something we might want to do as well, something that's good to know about if statements, by the way, and we haven't had to worry about this with the way that we've written our script, is sometimes when you write an if statement, you say, okay, if we meet a certain criteria, we might want to do something else if we don't write this criteria. And so that's where you can just write an else statement like so. And again, you can say if, and then just make sure you keep your squiggly brackets like this. And so, for example, on this one, what I might want to say is, okay, if the defocus size is not greater than 0, I might want to say in this scenario, okay, the output equals 0 or something like that. Just to say, okay, if we're not in the circle, don't include it. But for what we've done in the way that we've written it, it works fine like this. So now that we've got a defocus that works in just a standard 2-dimension global way, let's add an extra element to this that means that we can control it with a mat, similar to how a Z defocus might work. So the way we're going to do that is we're going to go into our BlinkScript. And while we're here, this isn't a blank kernel anymore. We're going to promote it to a defocus kernel. I'm going to call it a simple defocus kernel because obviously defocus has lots of extra features that we're not including. And what we need to do is we need to add an extra image to input, because right now it's only taking a source. And the way we're going to do this is I'm going to copy and paste what we had before, but on this one we're going to use access point. And the reason it's going to be access point is because the channel that we're going to be feeding and plugging in, we're only going to need the value on that single pixel to drive the blur, the convolution on this single pixel. And now when we recompile this, we're going to have an error. And the reason for that is because firstly, we need to change the name for this. And the name I'm going to use for this is defocus mat. And now when we recompile, it's going to error out because there's no input. And so what I'm going to do is I am going to grab a ramp like so. And I'm going to set this to have a value of 0 over here and a value of 1 up here. So when I view it and click replace, you can see we have this nice ramp. And now what we need to do is we need to say, okay, let's tweak a few things based on the size or on the scale of this ramp. And the way we are going to do that, and this is going to break a few things that we're going to solve in a second, is up here we're going to say we're going to take our defocus size input and we're going to multiply that by the value of this ramp. So if we had a, let's see what our value is. Our value is 16. When the alpha here is 1, we're going to say, okay, brilliant. That defocus size can also be 16. And when it has a value of 0, we're going to have a defocus amount of 0. And the way we're going to achieve that is we're going to create a new integer variable called scaled defocus size. And we're going to say that this is equal to our defocus size variable multiplied by our defocus mat input. And we're specifically going to put .w here because as we mentioned earlier, .w calls the alpha channel. And now what we can do is we're going to copy this and we're going to paste this into the location of where we wrote defocus size before. So again, this is going to break a couple of things, so I'm going to save this one. And when I click recompile now, and we view this output, you can see what we have here is a varying defocus going from 0 all the way up here. Now, one issue that you're going to see is that where we had a value of 0 on our alpha down here, or where it rounds to 0, we're getting nan values, which means not a number. And that is because when this will only loop on values greater than 0, so we need to add an if statement for everything to operate in. And the way we're going to do that is we're going to say if normal brackets scale defocus size is greater than 0, we're going to put all of our code inside this, and then we're going to write an else statement here, and we're just going to say output equals source, like this. And now when we put our semicolon at the end and we recompile, you can see we've got our very own variable defocus gizmo, just like that. So I hope this has been a great introduction to just sort of take you through step by step going from 0 to making a fully functioning defocus tool. And I hope you can kind of see that something that seems quite intense to begin with, it's just a matter of breaking it down into little bite-sized chunks, so that when you're done, and I'm gonna pop this out like so, you can see that using just these few lines of code, we were able to create a defocus. Additionally, I find with videos like this, it's best to maybe, once you've seen the full thing and you know where the end is, perhaps go back to the beginning and follow along again. And as you're going through step by step, not only are you going to be locking that information into your mind, but also as you're going and you know where you're heading, perhaps each step along the way is now going to make sense in the broader context. Thank you so much for your time. I hope you found this helpful, and happy comping.